Imagine you're standing at the very edge of the universe. No stars, no light, just emptiness. And then something happens. Out of nothing, matter appears, just like that. Sounds crazy? Well, physicists now believe that's exactly what's going on. Welcome to Cosmic Origins Revealed, where we get to the bottom of the biggest mysteries out there. This episode is scientifically reviewed, and all sources are linked in the description. So before we get to the edge of the universe, we need to start somewhere else, with one of the most stubborn puzzles in modern physics, dark matter. And, the name sounds dramatic, but dark matter is really just a word for a problem. We observe how galaxies spin. Stars at the outer edges rotate way too fast. Galaxy clusters hold together, even though they should be flying apart. The visible matter, everything that glows, radiates, reflects, it's simply not enough to explain what we're seeing. So there has to be more. Invisible mass, roughly 5 times as much as everything we can see. And this isn't coming from some wild theory. It comes from measurements, precise measurements, from the Planck mission, from gravitational lensing, from the cosmic microwave background. We know pretty accurately how much of it there has to be. We know how it behaves gravitationally, but we have no idea what it's made of. And now comes the part that really gives physicists headaches. For decades, we've been trying to detect dark matter directly. The idea was simple. If it's made of particles, so-called WIMPs, then every now and then, one of them should bump into a normal atom. For that, the most sensitive detectors in the world were built, deep underground, shielded from cosmic radiation. The LZ experiment in South Dakota, Xenon NT beneath the Gran Sasso Massif in Italy. And the result? Well, nothing. Again and again, nothing. And look, this single null result wouldn't be a big deal, but dozens of experiments over decades with ever-improving technology and still not a single signal? That's not a coincidence anymore. That's a pattern. And that pattern might be telling us we're looking in the wrong place. Maybe dark matter simply doesn't interact with our known physics, not through the electromagnetic force, not through the weak force, only through gravity. And if that's true, then you have to ask yourself, where does it come from? And right here, a door opens that is somehow pretty unsettling. In particle physics, there's a concept called hidden sectors. The idea goes like this. Alongside the particles and forces we know, there could be others, not far away, not in another universe, but right here, right next to us, in the same space, just completely invisible. Sounds like science fiction at first, I know, but this is mathematically grounded particle physics. Work by Yang Bai and Pedro Schwaller, published in 2014 in Physical Review D, describes a so-called dark QCD, a dark version of quantum chromodynamics. So, quick refresher, our matter is made of quarks, held together by gluons. That's the strong nuclear force. The proposal is this. There could be a second version of that. Its own dark quarks, its own dark gluons. They follow the same rules, but they have zero connection to our world, except through one single force, gravity. These dark quarks would bind into stable objects, so-called dark baryons. And you know what's fascinating about that? These objects could play exactly the role of dark matter, gravitationally present, but otherwise completely invisible. But now comes the next question. How do these particles become the massive structures that hold entire galaxies together? For that, we need to go back to the beginning, to the Big Bang. In the early universe, conditions were extreme, unimaginable densities, unimaginable energies. Under those conditions, dark baryons wouldn't have gently assembled over time. They would have been compressed, extremely compressed. When enough mass is concentrated onto a tiny point, gravity takes over. We know that. That's how black holes form. And in the dark sector, something similar could have happened. Compact, stable objects near the Planck mass. That's about 10 to the power of -8 kilograms. Sounds like almost nothing, but for a single particle, that's enormous.
These objects would be a kind of dark relics, remnants from the earliest era of the universe. They emit no light, they trigger no detector, but they have mass, and therefore gravity. And now comes the moment that turns everything upside down. What if dark matter doesn't come from a hidden particle world at all? What if it emerges directly from the structure of the universe itself? Okay, so this is where it gets really... Look, I'll be honest, this is the part where you need to think a little slowly. Our universe has a horizon, a boundary of what we can observe at all. Space is expanding, and beyond a certain distance, it expands so fast that light can never reach us again. That is, simply put, the edge. And this edge behaves physically similar to the event horizon of a black hole. And what happens at an event horizon? Hawking radiation. Stephen Hawking showed this in 1975. Quantum fields there fall out of equilibrium. Vacuum fluctuations, tiny, short-lived particle pairs that normally vanish instantly, get ripped apart there. The idea, described among others in work by Daniel Chung, Edward Kobe, and Antonio Riotto back in the late 90s, during inflation, when the universe expanded extremely rapidly, this space-time also possessed a horizon with an associated temperature, exactly as Gibbons and Hawking showed in 1977 for de Sitter space. And this horizon could produce particles gravitationally, without any new physics, solely through the geometry of space-time itself. The expansion separated emerging particle pairs so far apart that they could no longer annihilate each other. They became real, stable, and if these particles were heavy enough, say near the Planck mass, they could still exist today as dark matter. So what is at the edge of the universe? According to these models, the edge isn't a place. There's no sign that reads, "Everything ends here." It's a process, a zone where the structure of space-time itself produces matter, out of the vacuum, out of what we call nothing. And I think that's somehow the beautiful part about it. We went looking for the edge, and instead we found a mechanism, not an abyss, but a source. The truth is, we don't know for certain yet which of these explanations is right. Maybe the dark sector, maybe gravitational particle production, maybe something we haven't even considered yet. The researchers aren't in agreement on that. But the fact that these questions are being asked at all, with mathematics, with data, with real experiments, that shows how far we've come. If you enjoyed this journey, then subscribe to Cosmic Origins Revealed for more deep dive stories about the biggest mysteries out there. And if you really want to know what quantum fluctuations are, how something can emerge from absolute nothing, then write it in the comments, and we'll make that the next episode.